Hello, everyone, and welcome to the sequence of lectures about statistics. So, we're going to be working in this intro statistics notebook for the next several videos. And before we start talking about, uh, you know, probabilities and calculating different quantities, I want to talk a little bit about what statistics is and how it contrasts with probability. Probability, which we won't be studying in detail in this course, is the study of different types of random variables. It's the study of randomness. And probability, we're in the when we're studying probability, the kinds of things we're doing are writing down different probability distribution functions and taking integrals and computing, joint probability distributions, and that sort of thing. And it is very exact and mathematical and rigorous. In contrast, statistics is the study of how random variables tend to behave in aggregate, meaning if I have groups of random variables, how do the quantities that might describe this collection of random variables behave? And the crucial difference here is that in real life, we don't know probability distributions that, may lie behind the different events or we observe or measurements that we take. Instead, in the real world, we only have the measurements we make or the events we observe, and we don't know kind of the quote unquote underlying truth. We make models about what may be happening, but we don't. But we can only make particular measurements. And when we're studying statistics, we are trying to see if the measurements we make and the quantities that we can derive from those measurements match up with what we would expect them to be based upon some assumed probabilistic model. So that was a sort of wordy or verbose way of expressing these first couple sentences in the notebook. And the very tail end of that was referring to this part. We often want to use what we know about the behavior of random variables to make inferences and arguments. So when I make a claim to you, like unionized employees make higher salaries than employees in the same industry who don't have a union, I can then try and demonstrate that that argument is true by measuring salaries for unionized employees and employees without a union, and then calculating statistics for those two groups and comparing them to what I would expect the case to be if they in fact made the same amount. So let's unpack this idea of statistics with some examples. So when we talk about statistical inference, We often want to uh, do one of two things: either test some hypothesis or claim, meaning I make a claim, I say something is true, and we want to test whether or not what I say is actually true. Or we're doing parameter estimation, where, for example, we don't know what the average annual return of a stock is, but we would like to estimate it. In either case, we're usually using some statistical quantity to describe a group of people or events or measurements. So we might, some examples of statistics that you all are probably familiar with is, for example, an average temperature. And we might compare today's temperature to the average temperature for this part of the year. Or we might be interested if a change in stock price, how big that change is compared to the volatility of the stock, which in the language of statistics we call the standard deviation. So averages and standard deviations are examples of summary statistics, or statistical quantities. They are mathematical quantities that we calculate from a set of data. In hypothesis testing, we're usually interested in testing a claim about the value of some statistic. For example, if a stock price's increase, the increase of a stock price, is significant or just random chance, meaning is the increase in the stock price large, whatever that might mean, compared to the volatility of the stock. Or if there's a significant difference in salaries between employees with and without advanced degrees, we might start assuming that there is no difference, that the difference in average salary between employees with and without advanced degrees is zero. And then we collect some data and test whether that average is actually zero or if it's something other than zero. Or, for instance, we might think there's no correlation between the advertisements that a customer has seen, how many ads they've seen, and the amount of money they spend at a store. And then we might collect data about what ads or how many ads customers have seen as they purchase products. Or if we do this online, we might just know how many ads they've seen based on tracking clicks or page views. And then we know how much they spend as well. And we could compare, we could do a regression on those two quantities and see if that correlation is much larger or smaller than zero. So those are all examples of hypothesis testing, where we start out with some idea of what a statistical quantity is. And then we compare the statistics that we calculate from data that we have collected to that assumed value. We make a comparison and see if there is a significant difference between the calculated value and the expected value. Parameter estimation, we start by saying, I don't know what the average value is. I don't know what the volatility is. I want to figure this out. And not only do I want to figure or estimate what these statistics are, but I want to be able to say something about how confident I am about those statistics. So we might try and estimate the average annual return of a stock. And we might want to be able to say that we're 50% confident that the average return of the stock is between 3 and 6% per year. Or we might want to estimate the variances of salaries for a particular job across companies. So we collect salary data, for instance, for data science positions across many different companies. And at the end of the day, we'd like to say we're 95% confident that the variance in salaries for data scientists working at various companies is between $10,000 and $30,000. So the idea with parameter estimation is we collect some data. We use that data to estimate the value of some statistic that we're interested in. And then additionally, using our understanding of random variables, our statistical understanding of random variables, we can put some confidence on the upper and lower limits of that estimated value, that estimated statistic. The differences between these different modes of statistical inference and the nature of how we go about statistical inference or do hypothesis tests or make parameter estimates will become clear as we work through more examples in the notebook. But for now, I would like you to go back to this first paragraph and look at the examples given in the three examples given in this first sentence. Comparing the current temperature to the average temperature for the day, comparing a change in stock price to the volatility of the stock price, or wondering what the average salary of a data scientist is. And I would like you to answer whether each of these examples is an example of hypothesis testing or parameter estimation. I'm going to create a question on the discussion board. And you can share your thoughts for the answer to this exercise in that question. So this will be exercise. Examples of hypothesis testing versus parameter estimation. So after you've stopped this video, because I'm going to conclude here, you can go think about those examples, decide if they're hypothesis testing or parameter estimation, go to the discussion board and share your thoughts. In the next video, we'll start talking about estimating some statistical quantities like the mean.